again, well, this one's a little different, but it says Chloe is using a pump to drain her backyard pool to get ready for winter. The pump removes water at an average rate of 15 gallons per minute. So the gallons per minute, what I know about that is that gallons per minute is like my unit rate, right? In other words, what I mean by that is that I can come in, I know that my gallons is going to be my dependent variable, so my y-axis or my dependent variable is going to be the gallons, and that's the y-axis. I probably shouldn't use an equal sign. Y-axis. Because always our dependent variable is going to be the y-axis, so we got to keep that in mind. And then our x-axis, which would be down here, would always be, well, almost always be time. So our independent axis, or x-axis, would be time. And in this particular case, it would be time in minutes. And so, and the actual slope of this thing, the slope of this right here, this particular slope is what we would call the unit rate of change. So the slope would be gallons per minute. And that's basically it. And then because it's a straight line, we have to remember that that is what we would call a linear function. So that would be a linear function with a constant rate of change. Yeah, let's move this over here just a little bit so we can get it where we need it to be. So that's a lot of information. Make that a little smaller, I suppose. Get that to where we can see it. So let's reread this. So it says that Chloe is using a pump to drain her backyard pool to get ready for winter. The pump removes water at an average rate of 15 gallons per minute. That's our unit rate, which is also the slope. You know, because we know the unit rate, we know the numerator of the slope or unit rate is going to be gallons. And so that's the dependent variable, which is also going to be the y-axis. The independent variable would be the denominator of the unit rate, which would be the x-axis, which is in minutes. So the x-axis is measuring minutes, while the y-axis is measuring gallons.